CPSL 2018 Performance Video Verification and Test of 22-bit optical rotary encoder. In 2018, the 22-bit optical rotary sensor was designed and implemented by CPSL at NCTU. Also, we have success to implement the sensor on the rotary encoder and make it work. This video will compare both encoders using our sensor and with each company's encoder. The right side is our encoder and the left side is each company's encoder. Also, both encoders are coaxial to the motor. Two drivers connect to each encoders and read the information from the encoders. The computer monitor shows both positions simultaneously on these windows. The right side window shows the position of our encoder in single revolution and the left side window shows each encoder's position. Motor control and its state are shown in middle of picture. At the first, we are going to verify the position accuracy when motor rotating back and forward at 0.01 revolution per second. Obviously, the encoders have the same resolution in 0.001 level revolution. It also could observe that both encoders have the same position when motor rotating clockwise then stop. Setting motor rotating back and forward at 0.001 revolution per second gets the same result, which can even observed by naked eye. However, the plot shows tiny loss of distortion resolution, but it doesn't affect precision resolution in micrometer. Now we consider the limit condition of high-frequency signal process. Setting motor rotate at 10 revolution per second, which equal to 600 RPM back and forward. Both sides has the same position resolution in micrometer after randomly stopping during motor rotating counterclockwise. We can also get the same results after randomly stop during motor rotating clockwise. Finally, we set motor rotate at 50 revolution per second, which equal to 3000 RPM back and forward. Consistent outcome let both sides get the same position resolution in micrometer after randomly stop during motor rotating clockwise. We can get the same results after randomly stop during motor rotating counterclockwise. However, we can figure out that tiny loss of precision resolution attributed to motor rotating clockwise from position record plot.